Hello everyone, welcome back to my channel. In today's project, I'll be working on a fraud detection model that helps detect fraudulent transactions. Okay, so let's begin with importing all the necessary libraries like pandas for data manipulation, numpy to deal with arrays, and then we have date and time to to help us work with date and time related transformations, label encoder to encode a categorical data, and standard scalar to scale our data. We will be also importing train test split to split our data into training and testing set, randomized search CV, and some evaluation matrices to evaluate a model's performance, a decision tree classifier, and then smooth to balance our data, and joblib to save our model so that we don't have to train it again and again, and warning to avoid any unnecessary warnings. Okay, let's use the read CSV function from our pandas to load a data set into a data frame and have a look at it. First, we have loaded 25 columns, first 25 columns. First, we have transaction date and transaction time. Then we have the merchant. We have category, the amount, the city, state, latitude, longitude, city population, job, date of birth, etc. Let's have a look at the shape of our data frame. Okay, we have 14,446 observations and 15 features. And describe is going to give us some statistical information about the data. And info just lets us inspect the data types of our columns and the non-null values. We can see we have transaction date, transaction time. It's an object. We have merchant category, amount, city, state, latitude, longitude, the city population, job, date of birth, the transaction number, merchant latitude, merchant longitude, and a target variable that is fraud. Okay. And here we can see 14,446 are the number of entries and 14,446 non-null count. So clearly we can see there are no null values, but just to confirm, we are going to use the isNull.sum function. Okay, we can see 000, which means that there are no null values in our data frame. Okay, then we etc. Let's have a look at the shape of our data frame. Okay, we have 14,446 observations and 15 features. And describe is going to give us some statistical information about the data. And info just lets us inspect the data types of our columns and the non-null values. We can see we have transaction date, transaction time. It's an object. We have merchant category, amount, city, state, latitude, longitude, the city population, job, date of birth, the transaction number, merchant latitude, merchant longitude, and a target variable that is fraud. Okay, and here we can see 14,446 are the number of entries and 14,446 non-null count. So clearly, we can see there are no null values, but just to confirm, we are going to use the isNull.sum function. Okay, we can see 000, which means that there are no null values in our data frame. Okay. Then we have this transaction date and transaction time column. I do not need the entire column. I just want to extract an hour. So I'm going to use this from datetime function. I'm going to use the hour to extract the extract only the hour of the transaction. Okay. Here have a look. We have the transaction hour. Created a new column that says transaction hour. Okay. Then we have date of birth column. I don't think it is much relevant, but instead if I convert it into age of the person, it will add more value to my model. That's why I will use a current date and then convert to get the age of the person. We can create a new column called age. Look, we have the age of the person. Okay. Then we have two columns that are city and state. So we can merge these two columns into a single column because more number of features can sometimes lead a model to overfit. That's why we are going to combine these two features into single feature called location. Okay. We have location VLCK. Okay, we have joined those. Okay, now I'm going to drop all the unnecessary columns. I do not need the transaction date and transaction time column because we have already extracted the hour. City and state I won't be needing because we have converted them into a single feature. Then latitude and longitude, I don't think it is much important. And city, population, transaction number, merchant latitude and merchant longitude, and date of birth. So I'm going to drop all these columns. Now have a look at a data set. Now we have merchant, category, amount, the job, that our target variable, that is this fraud, the transaction are age and location. Okay, that's now we know that these are object or categorical columns, but let's have a look using the dtypes function. So we can see merchant is an object, category is object, job is object, is fraud is object. Okay, that's doubtful because it is supposed to be in binary numbers, that is either 0 or 1. So we'll have a look at that later. Okay, transaction is integer 8 and location is object. For our model, we are going to need all numerical features. So let's encode these categorical features using label encoder. Okay, now we can see all my categorical data has been encoded. Okay, then let's have a look at the east fraud column because it says it was an object. So let's have a value count. We can see zeros, it's 12,600, ones is 1,844, and then we have 0 and 1 into two string values. Okay, it's just a single value. We can ignore it or drop it, but instead, I would just convert it into uh, numerical. Okay, now have a look. But it has been converted. But if you see here, all my this data looks a little imbalanced towards 0, and it's a huge number, 12,600 compared to 1,844. So we will have to balance that before we start building a model. First, let's drop our target variable and save it into y. Okay, so this is the target variable. These are input features. This is the output variable. Okay, and I'm going to use standard scalar to scale my input feature. Okay, now I'm going to use train test split to, sorry, split my data into training and testing set. I'll be passing the scaled input variable y and set my testing size as 20%. Okay, and then like I said, as we observed earlier, our data was slightly imbalanced, actually a lot imbalanced. So I'm going to use a technique called SMOD and set the sampling strategy as auto, and I'm going to balance the data set and have a look at it. Now you can see it has been properly balanced. Okay. Now here I have defined a parameter grid for decision tree to tune hyperparameters, and I'm going to use a randomized search CV to find me the best combination of parameters that I can use that is going to give me best outputs. So we have these I'm going to use these best parameters and fit it on my data to and make predictions for both training and testing side. We can see the accuracy for training is 98% and for testing is approximately 97%. So there's just slightly 1% difference between training and testing, which means that a model is not overfitting. And also a classification report, have a look here. It states that a model is performing very well in identifying both the classes. 99, 84, 97, 93. So it is performing really well. We can see that decision trees are best model. So I'm just going to use dump dump from joblib to save our decision tree model, high encoder, and a standard scaler. Okay. Now this is something, you know, I'm trying to make prediction on unseen data. So I'm using the same columns that we have in our data. This is a unseen data. I've passed two set of data. I'm going to pass Amazon as my merchant, category as grocery, amount as $80, job as an administration, transaction hour is 10 o'clock, age is 25 years of age, and location as Wales, AK. And then Big Mart Electronics 150. And then I'm going to load my encoder and scalar. And I am going to say that whenever we have categorical columns like merchant, job, and location encoded, and encode those. And then if we have an unknown value, that is, but data is trained on specific set. Okay, so if there is some unknown data, then I'm going to transform that as well. Okay, and then use standard scalar and transform the data and try to make predictions. You can see the prediction, it has predicted 0, 0. Okay, thank you. And please like and subscribe for more content.